So shall we start this with a little toast, a little celebration?
A celebration?
A little celebration. Well, there's two things to celebrate, isn't there? There's one of them, obviously, is Perseverance making its way to Mars and landing safely, which is the
Indeed.
point of this podcast. And the second one, obviously, is you completed your first half marathon. So congratulations. Well done. I'm making it public for everyone to know. I know you hate... Well done, man. I am proud of you. Great work. Did you have fun doing it?
Thank you. I appreciate that. I did, but it was actually my second half marathon.
Was it your second? I didn't know that. I thought it was your first.
We did that one back in the first lockdown.
Oh, yeah, shit, we did, didn't we? Oh, bloody hell. All right, well, cheers to both of them.
Yeah. Yeah, I mean, we planned for the first one. This one was impromptu.
Yeah, huh? You're going to have to do a full one with me soon.
Mm-hmm.
Do a proper one. Well, it's not a proper one, doing a half one.
No.
I honestly think the half marathon is just as hard as a marathon. Once you've done the first half, you're basically done.
I cannot believe that people can do what I just did
twice
and then do it again. Yeah, exactly.
Mate, people can do a lot more than that. People do crazy things, but yeah, man, well done. Honestly,
thank you.
Great work.
Great
work. Madness.
I wasn't expecting that toast. You're making me blush.
Oh, bless you. So let's crack on with the episode then. As I mentioned a minute ago, we're discussing Perseverance landing on Mars with the Ingenuity helicopter and all things Mars. And as you'll probably see by the title of the video, we're going to get into some of the interesting things coming out of that with terraforming and all the bits and bobs that are on the rover that they're using to kind of understand Mars and how we can sort of develop systems to go there. So, which is quite cool because actually the launch quote for Perseverance, when the rocket took off and they started their journey towards Mars, the launch quote was the perseverance of humanity launching the next generation of explorers to the red planet. And that perfectly sums up the idea of why they've sent this one. Because I never really, I mean, obviously for me, I'm like, well, they're sending rovers out there to go and dig up rocks and see what the atmosphere is like and bits like that. But this one seems a bit of a shift. They're going to do more
because it's kind of it's like they're going there to not only do what the rovers have done before, so they've always gone there to try and figure out the composition of what makes up the rocks on Mars and things, and they're still going there to do that, like very similar to the Curiosity rover before, but this time they've actually they're kind of building the foundations almost for when people finally go to Mars, which is a really exciting thing because they're actually putting. So not only this one was an innovation in the terms that they actually put a microphone on this one, so you can listen to the Mars winds for the first time. But they also have tried. If anyone's seen The Martian, they've actually got a device on there called the MOXIE, where they're actually going to be trying to convert the Mars atmosphere into usable, breathable oxygen for when people eventually make it there.
So the MOXIE, I had something written down for this because I didn't want to forget it. So the MOXIE system is it's a little gold box inside the the rover, inside Perseverance, and it's got to be kept at 80 degrees centigrade. Do you know that? It's got to be really hot for it to work. But what it does is called the Mars Oxygen In Situ Resource Utilization Experiment.
Nice.
So what it is I'm reading this, by the way. It's an electrochemical process to convert Mars's 95% low-density CO2 atmosphere into oxygen. So obviously Mars is really low density compared to Earth, which is why it has no sort of atmosphere, or if you wanted to
1% the density of 1%. Earth's atmosphere.
Yeah, and then it's all CO2. And there's loads of CO2 on the poles of Mars as well. So it's got poles like Earth, and it does actually tilt on an axis and spin on an axis like Earth does as well. And on those poles, there's tons and tons of CO2, which we'll get into later with the terraforming stuff which is really
I didn't know
interesting.
about that, the localization of
Yeah,
CO2 pockets. I thought that it was just kind
yeah.
of obviously the atmosphere all over the entire planet, because I know that Mars doesn't have an active liquid spinning core like the Earth does, so it doesn't generate a magnetic field.
Well, well, they don't. It may do, and it used to generate a magnetic field.
Because it's not
Um,
tectonically active anymore, is it? But
no,
it looks like that it was at one point.
yeah. So I don't know. Have you seen the Planets series with Brian Cox?
I haven't,
He did a
no.
really amazing series. Definitely, you should watch that. You'd really
I
enjoy
should
it.
really,
It's
shouldn't I?
they did like all the planets as like had their own episode, and the Mars episode was like Mars and Earth as twins, like the sister planets, because they're really similar.
Yeah,
Mars is just a
really
lot
similar, but
smaller.
just chronologically kind of falling into
Hmm.
different time frames. It's almost like the Mars is like a glimpse into maybe what the past, no, sorry, the future of Earth is. Um,
Yeah.
once our liquid iron core stops generating that magnetic field,
Hmm.
once our tectonic plates stop shifting, once the solar winds completely blow the atmosphere off the planet, and life dies, that might be what Earth looks like one day.
Yeah. And we'll get into this again later on. I want to go through the Perseverance stuff first. I know
Okay.
it's really like all the terraforming stuff is so exciting, and
Yeah.
I really want to get into that. But the reason I want to do Perseverance first is just because a lot of the stuff with the Perseverance will work its way into how we actually explain the terraforming process.
Hmm.
Um, so part of the, I mean, let's start with this incredible landing that we
I
witnessed
know,
the other
right?
week.
Yeah.
Amazing. I
Crazy.
I couldn't I
Seems so
never
intricate.
realized, yeah, why like there was a really funny thing about it, right? So you know the delay between Mars and Earth for signals
Hmm.
coming back is like 12
8
minutes.
minutes. 8 to 12
8
minutes.
minutes. 8 to 12
The
minutes,
thing
right.
is, though, is obviously you've got like the sun, which is a one astronomical unit away from the
Mhm.
Earth, which takes 8 minutes for light or any signals to get to. But if you look at the orbit of Mars, obviously there are points when Mars is the complete opposite side of the sun to us,
Right,
because
okay, yeah.
we orbit. I think I can't remember the exact. I think 1.5 Mars years for one full revolution is
Is
3
our
Earth
year.
years. I think it's
Right.
3. So we go around it maybe twice. Basically, so if you look at the orbits of the Earth and Mars, they, the Earth is closer to the Sun, so it rotates, it orbits faster, which is
Mhm.
why they have to get that launch window just right,
So it
so that
lines up
it's
as
kind of
close as
like, yeah, the
possible.
points like that, and then Earth will overtake and leave Mars behind.
I
So
did think that.
yeah,
I
so the
did think that.
signal
How are they
sometimes is
doing it?
quick and
Yeah.
sometimes it's long.
Right, okay. I wondered whether they, because I don't know how long it takes for a shuttle to get to Mars, but I thought, were they
Depends on
gonna
when
have
you
to
launch it.
launch it depending on when it's gonna line up so it's closest,
Yeah,
you know?
precisely. Yeah, so between July and August 2020, and the next window would be between July and August 2022.
Right, okay.
So if
So
they
it's a long
hadn't have
old time.
launched it when they did, they would have had to wait until 2022
Oh,
before they could
jeez.
actually get the trajectory just right. Because I don't know
Mhm.
if there's any like gaming nerds out there like me that have played Kerbal Space Program, but like that shit trains you how to fly rockets to other planets. Like legit, you learn about delta V and like the apoapsis and the periapsis of orbits and changing trajectory to like retrograde and prograde burns and things, and like so when I full on like nerd out over watching like how they had to plan the orbital trajectory, because it's not like in Star Wars or something, which I think is a misconception, where people think, oh yeah, you get out in space, there's no gravity, and you just like fly in a straight direction and you get
Mhm.
there. It's like, no, you're always orbiting something. So it's like once you escape the Earth's orbit and you've got that escape trajectory, you're now on an orbital plane around the sun, and you have to manipulate that orbit so that it intercepts Mars's orbit. I'm going off on one. Sorry. Continue with
No,
your
no, it's fine.
Perseverance.
It's inertia, isn't it? That's the thing. You have to use the inertia of all these moving
Exactly.
objects, these huge.
Everything's
Yeah,
moving. Yeah.
yeah. Um, yeah, so with that landing, that 12-minute or 8-minute delay, obviously we're seeing that signal late. So
Late.
it's already
Yeah.
happened. So the
Hmm.
actual landing of the like when it came in, so when it hit the atmosphere and came down. Bear in mind that it's the size of a Mini. Or I mean,
Mhm.
with all the stuff and all the parachute and everything, it's way bigger than that. So, but it's
Yeah.
traveling 15 times the speed of a bullet. So you imagine a
Yeah.
Mini traveling
Yeah.
15 times
Traveling.
the speed of a bullet, and then it's hitting that atmosphere, which is not very thick. It's a really low density atmosphere anyway,
But it's still like it's still an
and then
atmosphere.
it's got to get to zero in the
Yeah.
space of the
Well,
atmosphere,
that's the thing.
so it
If
can
you have a
land.
thicker atmosphere, you can slow down. But the thing is like with the lack of
Yeah.
gas particles around you, it's even harder. You still need the heat shield and everything.
Mm-hmm.
But yeah, mental. And obviously, with that signal delay, it means that you can't trigger anything from Earth. You
No.
can't be like, right, deploy parachute now. Nah, like you've
No.
missed it by 8 minutes, which means it all has to be
Well,
pre-programmed.
the irony of the 7-minute landing is that at the very beginning of it landing, we're sat there all tense, like, oh, is it going to be all right? But it's already on the floor.
It's already there. Yeah.
It's already on the floor, and it's either smashed to shit or it's like landed perfectly. And we're getting all
Yeah.
tense about it, but it's already happened.
I know.
We just don't know about it
That's
yet.
the thing. On a more extreme scale, it's always like that, though. It's like when you're looking out at the distant stars in space, you're looking potentially like thousands to millions to billions of years back in time. It's kind of like, oh, imagine it, like watching some catastrophic event like the two black holes colliding. I know we didn't witness that. We only picked up the gravitational disturbances. But like, imagine we were watching that, like, oh, two black holes, like, oh, colliding.
300
and it's
million
like,
years ago.
Exactly. Yeah. It's old news, mate. Yeah. It's cool.
It's crazy, isn't it?
It is. It's insane.
Actually, yeah. What we'll drink for that?
Yeah.
Insane. Time is something that my fiance's dad wanted us to get onto with that, and I think
dilation.
This time dilation and stuff like that is very
Love
complicated. But obviously, you've got to think of time as a rate of change. You know, so time is, you know, if you said what is like speed is the rate of change of like, oh god, I'm gonna mess this up, of distance, you know, so it's distance divided by time, so it's the rate of change of distance is speed. So how far are you moving and how long has it taken? That is your speed. Now time itself obviously is what is a rate of change. So we age and we have like counted it in whatever we decide to count in seconds or whatever, but on astronomical levels, that rate of change is expanded so many times, and you know the light can only travel at a speed, so we are only seeing it. Oh, I'm gonna. Let's move on. we'll do a time episode.
I know what you're getting. Yeah, we will do
You
a time
do.
episode.
No one else
We'll
does.
actually like get fully into it. But yeah, like I say, like it's. Yeah, never mind. We'll do it. We will do it.
We'll do a time episode. We'll go back to my physics teacher. We'll have to get a physics teacher on to explain it for people. But yeah, that landing was, I found it amazing. And obviously they had the they landed and they had the like the little jetpack thing that like landed it slower by pushing down on
sky crane.
Mars. Yes, sky crane.
Crane with retro thrusters.
But that thing, once it had lowered it down, obviously they had to lower,
bring it down,
on like a little cord, the rover down from that sky crane, and then once it had hit the floor, that sky crane just blew up all its fuel and flew off like across the atmosphere.
As it would have to. Could you imagine if it just like dropped off the rover and then just came down and landed right on top of it? Like it has to obviously like shoot itself off. Make sure that it's safe distance away. But yeah, what a design. But it makes so much sense, doesn't it? I mean, they did the Curiosity one like that as well.
They did, yeah.
But like, I really like the one they did for the Pathfinder Sojourner. And
that was the first one, wasn't it? Sojourner.
That's the first one. And then there's the ones I always forget their names. Yeah, it's the size of a microwave. Yeah. What's the other two?
So you got Curiosity.
Yeah.
Spirit and Opportunity was the first two. So the second two. So you had Sojourner. Sojourner was first. That was tiny. Then you had slightly bigger was Spirit and Opportunity. They were like twins. And then you had Curiosity, and then you had Perseverance with the Ingenuity helicopter. And that Ingenuity helicopter is amazing.
I want to get into that because that thing is super exciting.
Not just for taking photos of each other.
No, exactly.
That is also cool.
Yeah. I feel like they just had to use that as like a justification, thing. It's like, oh
Hmm.
no, it's going to be it will be a recon drone. It can scan the terrain and decide the best course for the Perseverance rover to take. But no, I just wants to take some cool selfies.
Mate, the thing with that Ingenuity helicopter, the thing that's so cool about it is if you had multiple, like as we're sending more and more stuff there to maybe do
Hmm.
some more recon and stuff, um, depending what they find in that, those helicopters can be really useful as like drones to move things way quicker because
Oh yeah,
the rovers are slow, man. Like that's why they have to be so
so it
accurate with
goes
the
at zero
landing.
point 0.1 miles per hour.
Yeah.
That's
So
that's how fast it goes.
the target landing, obviously they've landed it in the Jezero crater.
Hmm.
Maybe we'll get onto that in a minute while we're on the Ingenuity thing.
Yeah,
But so they've landed it in the Jezero crater, but if they wanted to land it there, and if you don't land it where you need to, then it can take you like years to drive to a more
exactly.
suitable place. So
Which is another benefit of the sky crane. It gives you that kind of. It almost acts like a helicopter in a way. Like sling loading is a really common way of delivering things with accuracy on Earth. You get a helicopter because the helicopter can move kind of.
laterally,
Yeah,
horizontally.
yeah, horizontally with and this stays relatively stable. So it's kind of like if you've got a bad landing zone, you can. I mean, I don't know how far you'd be able to travel with the sky crane, but like you say, like because landing in that crater was of great importance because that was a delta. It's a delta, so it's
What do you mean by
potentially
delta?
quite likely it's like a river basin.
Yeah, yeah, yeah. Okay,
So
cool. Is that is sorry? I think I
like the
misunderstood.
Mississippi Delta.
Oh, okay, cool. You just
Yeah,
it's like an actual it's an actual thing. I thought it was
yeah.
like a space term that you were like,
No, no,
"Oh,
it
yeah,
sounds
it's
like
a
it.
delta
Yeah.
landing zone." Oh,
Landon
okay.
Delta.
Nope, it's just a delta.
Yeah, yeah,
Cool.
it's just a river.
So it's like a historic lake, isn't it?
Yes,
It's an old historic lake from when Mars had water.
exactly.
And what they're trying to dig up is fossilized, mineralized remains of potentially microscopic life.
Very early, yeah, yeah, very basic, yeah,
They're
microscopic
hoping they
life.
can find very basic life, not because they're like, oh, that we want to find life and stuff. It's more that they're like, is this
It's a
planet
proof
has
of
this planet,
concept.
yeah, has this planet ever been sustainable for life?
Mm.
Because
Because it's
hundreds of
looking
millions of years
increasingly
ago,
like it.
well, it
Yeah,
definitely had water. They know it had
yeah,
water.
exactly. Yeah,
So that
and
I
if
mean,
it happened that close to, because the thing is, it's always cool. We're referred to as Earth being in the Goldilocks zone.
mm,
Um, of the perfect distance away from its star, the perfect, our spinning liquid iron core, all like the perfect prerequisites for life, which we've never really actually obviously gone and seen exoplanets properly, but like we're not really sure how common these things are. But imagine
well,
finding
they had that
that
telescope,
life,
didn't
but yeah, and imagine finding that life. Okay, so we knew that Mars had some kind of liquid. It could be like Titan, you know.
they?
It could have had it could have had liquid gas or something. I don't know, like Titan, because I want to get into Titan as well because the Ingenuity helicopter. I know I'm going off on a tangent, but the Ingenuity helicopter is a proof of concept for um, for drones or rovers that can travel through the air, and that's what they want to do on Titan with the
Hmm.
Dragonfly, which is going to be a quadcopter, which they can fly to Titan. And Titan's really exciting because that's probably I'd be more excited about sending something to Titan because that actually has rivers, clouds, rainfall, but it's all
Hmm.
liquid methane instead,
Oh, geez.
and
Well,
that's
methane,
amazing.
yeah, methane is something we will definitely need to get onto with the terraforming stuff. Um,
Yeah,
that's interesting that Titan has, so it doesn't have water; it has liquid methane, and that is its
liquid
atmosphere is
methane.
made of
Its
mainly
atmosphere.
methane.
It looks like, imagine if you imagine Earth, obviously minus the plants, but like how
Yeah.
you have rivers and how you
Hmm.
have lakes and how they evaporate up into the sky into clouds and then condenses and falls as rain. It has all of that except it's methane.
And I suppose methane's not suitable for sustaining life
No,
in
unless you had
carbon-based
some
life forms.
exactly, unless you had a because that's looking at life as we know it, like say carbon based.
Yeah.
But there's nothing to say that there couldn't
Argon-based
be
life forms, potentially.
argon based life forms. Exactly. Yeah.
I just pulled
Exactly.
that
So
out of thin
that's
air. That could be a load of bollocks.
yeah, gas. But like, I don't know, because methane on Earth is a gas.
Yeah. So
So
why is it a liquid there? Is it super hot or is it super cold? I guess it'd
well,
be
you know
cold.
what? It's
Cold because
very cold. It's
It's
super cold.
Jupiter's moon, is it
It's one of
Titan?
Jupiter's
Yeah.
Galilean moons. Yeah, so it's
Yeah, it
no,
must be
no.
freezing.
I was thinking about Europa. Europa is the other one I wanted to talk about later because that's one of Jupiter's Galilean moons. Titan is
Right.
Saturn's moon.
It's Titan's Saturn's moon. Right. Okay.
Yes,
Cool.
but it still is. It's like
Yeah.
minus.
If you were sat there in the comments furiously typing, it's Saturn's moon.
Yeah,
He's
don't worry.
he's
I know
already
it's
corrected himself.
I'm just I get so excited about these things. I'm just like, yes, yes.
Yeah. I mean, actually,
It's really
temperature is
cold.
massive. Yeah,
Yeah.
temperature is massive. So methane is liquid when it's freezing cold. Then.
Yes, I don't know
Okay.
actually if it might be to do because it's smaller than Earth, so but it might be atmospheric pressure as well. I
Right.
don't
Okay.
actually
Yeah.
know that,
A lot of
but
that
like the
comes into it.
density,
Hmm.
because one of the things about the Ingenuity helicopter is it couldn't be a quadcopter like we have drones on Earth
Hmm.
because the atmosphere is so thin on Mars that
Yeah.
its blades need to be like a meter long.
Veritasium did a great video on that. He released it about a year ago because they obviously announced they were sending up Perseverance with the Ingenuity helicopter. So there's a channel on YouTube called Veritasium, and he's got
Mhm.
a video. It's called. I'll link it in the description, but it's called something like "This is the helicopter that's just landed on Mars," because he's changed the title now that it's landed, and he goes into it, and he actually goes to see the designers and plays with the actual Ingenuity helicopter that's going to be on Mars. Um, and he goes into the the huge blades and the fact that it can't be a quadcopter and all that sort of stuff. But it's
Mhm.
interesting because obviously it's so different to how we would design something on Earth, and they've
On
obviously
Earth,
had to factor in all of that
all
to
of
make
that.
something work
Yeah,
in a different atmosphere. Because driving something on the ground, as long as it's heavy and it's stable, it's fine,
exactly.
even if
It's going to
it's
work the
ground
same.
based. But in the
Yeah,
air, massive
using the
difference.
density of the atmosphere to propel yourself, yeah, is
Yeah.
obviously going to vary greatly on and same with Titan. So obviously on Earth you'd design a helicopter with a rear blade to counteract the force of the top rotor spinning
Hmm.
would spin the helicopter, so you have one placed sideways on the tail which would stop it from rotating, but they can't do that on Mars because the blades have to be so big, so they have to have two alternating, so one spins
Stabilizing
one
one.
direction, one
Right.
spin one direction and the other spins the other way, so they counteract each other so it remains stable.
Ah, okay.
Because if you look
That's
at
interesting.
helicopters on Earth, they all have a blade at the back and one on top,
Yeah. Yeah.
apart from
So does that
I'm
not
really
kick up
going
a
to
load of
nerd out.
turbulence? That's crazy.
Yeah,
That's something I'm going to look into a bit more, I think.
yeah. They
Really
do actually
interesting.
have a helicopter. The Black Shark, which is a Russian helicopter, has alternating, and the
Oh yeah.
Chinook as well. Because
Oh
if you
yeah.
look at Chinook, that's got to. Yeah, I'm not going to go into helicopters.
Yeah,
I'm
don't
just
go
a
into the Russian stuff either. I can see the Russian on the back wall there,
I
mate.
put that up just for you, man.
Comrade Rob.
Subliminal messaging to get all the viewers
I
over to
knew you were. I knew you were.
my.
You just gutted that USA got there first, aren't you?
Yeah,
Bless
communism
you.
is the way.
No, it's not. This is a running theme here, mate. Everyone's like, "What the hell is going on in this fucker?" The other thing that's really cool, obviously, with the fact they land in the Jezero crater, is their little drilling bits. So they're not just drilling anymore and collecting tiny samples. What they're trying to do now is to collect samples that they can't actually like break down and look at on there. They want to look
No.
at Mars through with like the technology that we only have on Earth. So what they're
Hmm.
doing is they're digging down and pulling up little chalk pieces
Yeah,
of
and leaving them
rock
behind.
and leaving them behind.
Yeah.
For some, so it's like the first stage of a 3-stage maneuver, which Mark Rober, who's another YouTuber, called the poop, scoop, and shoot maneuver. So, have you
I
heard
have
that
heard that.
before?
That's
So,
genius. But
he calls it
that's so perfect for
the
it.
poop, scoop, and shoot. And it's basically
Yeah,
the Perseverance digs down, gets up a bit of chalk,
yeah.
poops it.
Leaves it
The
behind.
next
Poops
stage
it.
is
The
something
next
comes and
one
scoops it. Yeah. And then
scoops
the
it,
third one
and
sends it
then
off to back to
gets
Earth.
shoots
Testing.
it back to.
Shoots it.
But I heard that they're not going to be able to do that until like 2028. So we won't actually get our first little poop
No.
samples back until like the 2030s.
Little poop samples.
Yeah.
Amazing. I was like, that's incredible though. They're obviously planning for the future, and that's part of what they're doing with this, which is like you said about the MOXIE earlier, with their, they're trying to get
They're
things
like
in a
setting the
line, yeah,
foundations.
for more
Yeah, yeah.
travel and more
Hmm.
things, which is great. Which is exactly what you want from a rover. You don't want it to just go up there and be like, "Here's some photos, here's some samples."
No,
I
but
mean,
have you
obviously with the other
seen the
ones,
photos? Because they are amazing.
they are incredible.
Like
They really
the
are. I
photos
mean, we
are
put one
so
up on
good.
our Instagram, on our story, and just like we were really impressed by it. But um,
I've changed my wallpaper on my phone. I'll show you. This is the Curiosity rover.
nice, nice. So it's awesome. Obviously, the photos and
Mm.
they're really valuable in terms of assessing the land and stuff. But
It's
it's the
it's
smallest part. It's the
it's the
smallest part.
smallest part. The only thing that I'd say it's significant for is raising awareness, like public
Yeah.
opinion of like the Mars missions and NASA and things as well, because that's something that's really important. Because I think space exploration is something which is overlooked
Well,
massively.
actually, I mean, there's a really good thing actually going on to the sort of the terraforming stuff. Um, Neil deGrasse Tyson made a really good point on this. He said, at the point that we can terraform other planets is the point when we can terraform Earth. So all this global warming that's going on, and we're saying, oh, this is, you know, devastating on Earth. With the atmosphere's thinning, or any problems like
Hmm.
that. If we have the capability to terraform Mars, and I mean, we'll get on to the sort of timescales of this because we don't know how long it would take. It could take thousands of years to terraform a planet.
Yeah,
It could take
exactly. Yeah.
millions. We just don't
Hmm.
know. But
Hmm.
if you could terraform Mars, then you could terraform Earth, and you could
Yeah.
it's a case of understanding the geometry, the geography, and sort of the atmospheric computational processes that you'd need to, do I need to add heat? Do I need to add,
Exactly. Like if
methane?
you
Do
can
I need
take
to?
something as barren and an atmosphere as thin as Mars and reverse what's potentially, like, we don't know what Mars was once like, but what's potentially billions of years of complete desolation, and
Mm,
turn that into a habitable planet, it should be easy to do it with Earth.
it's already halfway there.
Yeah,
Yeah.
exactly. Like, it's like you say, it could take a long time. It depends on what you have to do to it. I mean, obviously, you'd have to pollute it. You'd have to cause a huge amount of gases to
Hmm.
give it some kind of
You'd
atmosphere. You'd have to almost.
melt off the CO2 ice caps.
Yeah, yes, yeah.
Elon Musk had his idea for it would be to get like huge mirrors essentially that you would have orbiting the planet facing the sun, and essentially like when you get your phone and you like shine the light from the sun into someone's eyes when you're in school
Hmm.
and you're like or your watch. That's what you'd be doing with the
Just do
planet,
that onto
and you
the,
just
yeah.
aim it at the planet, so you're just adding so much heat constantly to the point where the polar ice caps, or the CO2 polar ice caps of Mars, would melt, release the gas. Now obviously you'd have to do so much because it would, when you first do it, it's just going to, like, the atmosphere is not dense enough to capture it, so it would
No,
just be
it just
leaking
get
out.
blown off. Yeah,
But the more and more you release, um obviously the thicker and thicker the atmosphere would get.
the more shit
And
sticks.
when it starts really thickening up, that's when you start having um an atmosphere that's dense enough to
Hmm.
sort of start storing things, and that's when you can start getting more heat, and
Yeah.
then the process just does it by itself. And um and that's how you'd warm up the center of the planet.
Hmm.
It would take, I don't know how long it would take, probably thousands of years, but
With our
there's ways to do
technology,
it.
We
Yeah,
could we couldn't. We'd have to make significant technological
no.
advances. It would take
They
us a long time.
obviously methane on Earth is a huge one. That's how we warm up our planet.
Mhm.
Humans expel methane, so do cows. Obviously, usually it's things with like multiple stomachs are really good at producing methane. Like cows have multiple
Methane.
stomachs, so they're constantly burping and
Yeah,
farting. And same with like termites, two stomachs, great. They devour tons of food and then just leak
yeah.
gas. So you'd want
But
to
we
take a
don't
load of
want that
termites.
here.
No, we don't. We don't really want that here. No, but you could take a load of
But that's
termites
what
to
we'd
Mars.
want to do to Mars.
Mhm.
Yeah, exactly.
But you'd
Kind of.
have to take a load of termites and fuel for them to burn. So you'd have to give them stuff to
Mhm.
eat there as well. So they called it BOYM, bring your own methane. Like that's the only way to do it because
Yeah.
you probably wouldn't be able to get enough just off the planet, or if you did, it would take so long. Um,
There's SpaceX's rocket as well. I can't remember which one it's called, but would actually have to go out and to have enough fuel to bring itself back, it would have to come up with some way of generating its own fuel using methane as well.
right, that's interesting.
So yeah, lots of
I mean,
uses for
energy,
methane.
obviously. I mean, we can go really basic here and obviously say about the transfer of energy, and that if you can if you can store it some other way. So anything that you're space is quite an easy one because you know even doing anything at speed is hard, but doing anything slowly is pretty easy in open space because
Mm.
if you just throw a hammer away from
That
you,
gives you
that
enough.
gives you enough like pro- propulsion to move momentum to
Yeah,
move the other way. Um, but it's just speed,
good old
obviously.
Newton.
To get more speed, yeah, literally, force is mass times acceleration, and all all energy is equal in an equation, isn't it? Um, but in order to get to speed, you need tons of energy. So
Yeah,
I guess it's a way that you'd have to. There's ways you can do it
and
though.
then
We
energy
can
to slow down.
convert human energy into other energy. You can power a light with a bicycle and stuff, can't you?
Something I did want to talk about. So on the topic of energy, I really like as well because did you see how they're powering Perseverance? It's the same way as Curiosity, but it's with the so it's a radioisotope, which
Yes,
means that it
yeah. It's like
charges itself.
nuclear. Yeah.
Yeah, yeah. So it's kind of like nuclear, but not using it the same because obviously our nuclear reactors use nuclear fission.
Is it fusion? Is
Um,
it?
it's not fusion. It's not actually a nuclear reaction at all. It's just purely the fact that they are hot. So plutonium 238
Oh.
is
Mhm.
hot. Um, and if they have that, oh god, I'm gonna butcher this, but basically, if you have a radioisotope which generates a lot of heat, and then a conductor, and then something which is very very cold, it transfers electrical things, and power is generated, and magic.
Right. So it's essentially like a good way to look at it would be like like a water turbine when water comes through it and it turns around itself
Kind
with
of, but like,
water.
because that's how fission reactors work, isn't it? They superheat water, and then steam turns a turbine, and that is what generate like that's what generates electricity. But this is kind of like a crude reaction almost between
Mm.
heat and cold, which transfers electrons. I really don't understand it. I was watching a video on it, like that's genius.
It's all really hard though. I find I'm not very good with chemistry at all, and I find all the stuff with isotopes and fusion and fission and all that stuff really confusing. I've
Me
always
too.
found that sort of stuff confusing though. It
It
is
is
just
very
odd.
confusing, but it's cool.
Um, it's amazing. Yeah, it's
Yeah,
amazing what people can do. And obviously, why are they not using that technology on Earth then? I suppose it only generates a small amount of energy.
110 watts, kilowatts. I can't remember, but it's not very much. It really
Yeah.
isn't very much. It's just the fact that and also it depends on the half life of plutonium 238
Yeah.
to
So yeah, as it
decay.
decays, it's going to be
Yeah,
yeah. That's fair enough. That makes sense. What is the half
so
life? It's quite long though, isn't it? For
14 years.
right. Okay.
Yeah,
Yeah, that's all right then. We know we
yeah.
probably won't need it after sort of
That's the
28
thing,
years,
isn't it? It's kind of like,
36
well,
years.
I don't think we'll need it for that long at all,
No.
really. Like, if that's way longer than the mission time projections. But that's
Yeah. Yeah.
um God, I can't remember the company. You might have to help me out here.
Go
J
on.
Jet Propulsion, is it JPL?
Oh yeah, Jet Propulsion Laboratories. Yeah.
Yeah. So
Yeah.
they are known for over engineering.
Yeah, but you've got
things.
to, haven't you? I mean,
Yeah,
what was it Solar Journey that they said about it should only last X amount of hours, and it lasted like 300 times that.
way past
Yeah,
what it
like
was supposed to.
yeah, which is great, which is what you want because then you've got
Yeah,
more data, you know.
yeah,
Yeah,
definitely.
it's awesome. I mean, obviously with the MOXIE stuff, going back to that sort of electrochemical oxygen, that would be good for when you can't terraform. So like pre-terraforming, you'd have to, if humans went, they'd have to go in biodomes.
Hmm.
So in order to do that, you'd need oxygen creation because you can't just go there with oxygen tanks because oxygen is, if you tank it up, is so heavy.
Hmm.
You know, so like to carry all your own oxygen there would just be absurd if you wanted to have any large scale mission.
Yeah,
Um,
yeah, which is why the Moxie is
with the
such an
Moxie thing's
important.
fantastic, and if that
Yeah.
works, if they can prove that with a proof of concept and make
Hmm.
that work, and then have the drones, you know, flying things to and from sites,
Hmm.
you know, if they had
That's
multiple
it. You're
drones,
well on your way to being
biodomes,
able
you're
to
well on your
actually
way to having,
colonize.
yeah. Well, not, I mean, colonizing is a strange one, isn't it? Obviously, without terraforming, colonization is an
I mean,
absurd
purely for
idea.
scientific, so not just
Yeah,
sending people to live there. I mean,
no.
sending like in The Martian, I guess.
Yeah, I saw a really funny one. Someone said, "Oh, you want to go and live on Mars? Why don't you go try living on Mount Everest for 3 months and see how that goes first?" You know what I mean? Because that's way more
Yeah,
habitable
hospitable.
than, yeah,
Yeah,
hospitable than Mars is. You're like, yeah, that's a
it's
very good
very
point.
true.
Actually, there's still oxygen up there, isn't there? You know? Um,
Yeah,
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 it's mental,
definitely.
isn't it? But yeah, absolutely crazy one. I'm gonna have to go for a piss. So you carry on talking. I'll
Okay,
be back in a minute.
I'll
I'll edit
patiently
this
wait
out.
here.
You'll see
Okay,
me back again.
okay, cool.
Imagine pissing in zero gravity.
Oh,
Horrible, wouldn't it?
because you
This
know
is
that
bourbon there.
it all sticks together in zero gravity as well under its
Yeah.
surface
They have to
tension.
stick straws in it, don't they? They have to stick straws
Yeah,
and
so you literally have a
horrible.
pee bubble floating around in front of you.
Although it's good for heat, so if you need a nice water bowl, that's a great
Yeah,
option. Oh,
yeah.
dude, I think we should probably get into the hypotheticals here because
Okay.
this is the fun bit, isn't it? It's your chance to be a existential transhumanist, as you would say. How is humanity going to
Yes.
get there? You know, um, obviously, if you did
Yeah,
start
yeah.
terraforming, and if you could live there, if people could go and colonize, other planets and Mars, say as the first stop, what how does that work? If you look at the two, um, people obviously say, well, are you a Martian or are you human or, sorry, Earthling or, you know, what was your, I'm going to restart this whole bit. I'll mess this up. If you have two planets, if you have two planets, which one would you want to live on? If you're on Earth, if you're
Which one
born
would
on
I
Earth,
want to live
yeah,
on?
which one would you prefer to live on?
I guess I probably see it with a bit like more of a possibly unrealistically utopian kind of lens on the whole thing, that there wouldn't be like planetary identity and
Do you
being
not
like,
think?
we're from Mars. Like, I guess that's probably more realistically what would happen.
You think?
But
Yeah,
then how I see it is, um, so I kind of take Elon Musk's perspective on it, that the thought of humanity not being a spacefaring civilization is something that I find immensely depressing. Like the thought that we don't spread amongst the
yeah.
stars is just, I can't accept it. It's devastating. Like, Earth is where we are from, but I don't think Earth is where we belong.
What do you
You
mean
know,
belong? Of course, we
Earth
don't
is where
belong.
we're from,
Yeah.
but Earth isn't necessarily where we're meant to stay.
You mean you want to be more of a
Which I guess
frontier
might be,
spirit?
yeah. There's more out there. Like, there's so much more out there. This, you can't forget about Earth, but I guess it might be an unpopular kind of viewpoint on it. I still care about the Earth. I don't want to ruin nature and the environment and like use it up for all its resources, screw it up into a ball and toss it in the trash, like, up, done with you now, Earth, we're going to move on to other planets. I don't mean that. It holds significance, but at the same time, there's more out there. Like that is where we're supposed to go, in my mind. And
Yeah.
Mars would be the first, the starting blocks for that. And the thing is like, you can't. Okay, so right now, like extinction events.
Yeah.
If you had an extinction event on Earth, that's it. Like the dinosaurs, like humanity's gone. The tardigrades will take over.
I don't know though,
But the
because I
thing
think
is
at the point
once we
I hear what you're saying there with the destruction of a planet with like an asteroid or a meteor or something. I think at the point that you can terraform a planet, your defense mechanisms are going to be pretty in place because the technology it would take to be able to
well, then
terraform
you
where
can't be
people could live
stopped.
there. Yeah, no one's like no asteroid is
Yeah.
going to affect your. I
Then
think once the second you've got a second planet terraformed and done,
once you've
you're
spread
fine.
to other planets, once
Yeah.
exactly, then that's it. You're never stopping humans then.
What species would you take with you? Because you can't. We need plants for one thing. They oxygenate places.
Yeah.
What animals are you going to take? What? I mean, what would work? What would do well there? What would thrive? It's hard, isn't it? Like, are you going to take bugs?
You mean like once it was terraformed? I guess you'd have to judge that on what kind of climate you'd terraformed it to. And the thing is how would that even work? Because
that's the thing, isn't it?
Because Earth works on like an equatorial
Seasonal.
basis, where obviously our north and southern poles and things. Yeah, seasonal.
So does Mars.
That is what's cool. Okay, so once it was terraformed, you'd assume that it would actually follow the same kind of cold north and south poles and an equator which is warmer.
Roughly, yeah. It definitely has seasons.
Because I don't know.
Yeah, definitely has seasons.
Because you said because it rotates on an axis.
I don't know how hot you'd make it. I mean, I guess if you could make it as hot as you wanted to, couldn't you? Like if you're adding, if you can pump the density of the atmosphere to whatever you want, then you can make it as hot as you want at that point. A proximity to the sun is no longer an issue.
Yeah, that's the thing.
Strange one though, isn't it? And also, my other question is this. This is something I'm really interested in. If you terraformed Mars, right? Say you went up there, you took a load of bugs, load of whatever, took a load of animals and a load of bugs and a load of plants. What would be the first? Imagine the first thing that naturally was made on Mars,
or like evolved.
Yeah. So, all right. Like, imagine this for a thought experiment. So, imagine. Yeah, maybe I didn't. Again, I'm dreadful at explaining things, mate. So let's say we terraform. Let's say we terraform Mars, and then do nothing. We don't even live there. We just terraform it and leave it. Let's take away all the other stuff. So let's not take any animals or plants or humans. Let's just terraform and leave it. How long until life evolves by itself?
You know what? I think that would probably be almost as, maybe not with the first planet that we terraform, because we want to spread.
Yeah.
We want to spread out, and so we can actually live on other planets. But oh my god, would that if we don't figure out the origins of life by the time that we're terraforming other planets, that is such a good idea. Because
how long does it take? What are the perfect recipe?
That could be the answer to everything.
Because then we have the power.
Because we still don't know. Like, we have no idea what that. Exactly. We don't know what that point was. We can't observe that point. We estimate that it's something like 3.5 billion years ago. The Earth has been around for an estimated 4.5 billion years. And it's like, we can't know. We can know an awful lot about early life, but we can't know just that crucial moment that it poofed into existence. And if you could study a planet, if you could study a planet in its early stages,
you need to know everything, because where did it first start? You're looking for, oh mate, imagine that you terraform it, you leave it, and you go, we've not added anything.
That would be an awesome experiment.
Yeah.
Well,
they think that some of the
from what you were saying then,
Go on.
Sorry, I think there's a delay. There's a
Yeah,
delay
yeah.
in the connection again. I was going to say, what's to say that that's not what we are on a larger scale?
This is what I was going to say.
Imagine that's how we came about.
This is what I was going to say. So
That we are an experiment, as in someone else wanted to learn the origins of where they came from, and they wanted to see life beginning in the and how it started, and they created maybe not just Earth, but like our entire universe, because
yeah.
maybe that's small
And
to
what? And then
them.
they just gave up and lost interest a couple of billion years later and wandered off and
No,
never
it's
came
still
back.
early stages.
Yeah.
I mean,
Jeez.
yeah, I mean, I'm bored of us.
Fair enough. Yeah, it's interesting, isn't it? The in terms of you're saying about what if there was, what if we came in on a meteor? A lot of the water that we have in our planet comes from asteroids. Just like they're little tiny
Yeah,
microbe asteroids that come in. They just fall through the atmosphere, and they all
yeah,
contain water. So a lot of the water on Earth would have originally come from millions and millions of tiny little asteroids carrying water molecules that would have then created the
carrying
oceans.
water. Yeah,
Yeah,
so
maybe microbes came in on them. Maybe there is
which
spacefaring life, because life is interesting when it
I
goes
mean, there
that
kind of
small.
has to be. Yeah, it
Life
doesn't.
is weird when it's
Yeah, you're
small,
right.
isn't
It
it?
doesn't follow the same kind of rules. Yeah,
Yeah, it doesn't need so much. Maybe it does. I don't know. Space is a vacuum. I guess even microbes would struggle in space, wouldn't they? Yeah, they would.
some so like what was it? So like I said, the tardigrades, they can survive in a vacuum. I
So
don't know
what's a
how long for,
tardigrade?
and they're like a complex. Uh they I heard about them on a Neil deGrasse Tyson thing. Um, they are microscopic,
Right.
but they are complex. They're not like a cell species,
Yeah.
and they can survive in sub-zero temperatures. They can survive in active volcanoes. They can survive in liquids of pure acid, and they can survive the vacuum of space.
Jesus.
So they're kind of like
These
the
things are
perfect
resilient,
being.
mate.
Exactly.
Nuclear
Yeah,
bomb
I
goes
don't think
off,
they
they're
can
not worried
survive
at
it for
all.
like a really long time. No,
No, but
exactly. Yeah,
small. Yeah. Jeez, man. Yeah, life is resilient and when it's small. It's funny, isn't it? Because the larger life is so weak in comparison to its microbial versions of itself. The things that live on us would live way outlive us in terms of heat and um like extremes and
yeah. They've got
food
yeah,
shortages and
way more like say resilient.
yeah.
Yeah, definitely.
So there is, there potentially is still fossilized life on Mars just sat there waiting for some more heat for it to kick back into gear. There probably is everywhere. I mean, you say about
And
the,
then
the
hopefully,
just billions of exoplanets in the Milky Way alone, because there is like
hmm
billions in the Milky Way
it's a
alone of
ridiculous amount.
habitable
It's a
planets in a Goldilocks
ridiculous
zone.
amount. Yeah,
It's crazy,
yeah, yeah,
and we
exactly.
just it would just take us
And they
years and
don't even
years and years and
necessarily
years and
have to
years to
be.
get there. But
Yeah,
no,
yeah, I know.
mad
And
one.
have you seen like those the scale of the universe things where it starts off with the Earth
Zooms
and
out.
then and zooms out and you've got Jupiter, which is like, wow, it's so huge, you can fit thousands of the Earth in that thing, and then you zoom out even more and you have the sun, and the sun is fucking gigantic, and then you zoom out even more and then you see like the other stars like Alpha Centauri,
Yeah,
um, and then
just
you have
dwarfing.
like Canis Majoris, like the stupid, like to the point where it's taking up the entire screen and you can't even see the sun anymore. It's like a pinprick in the corner of the screen, and then it starts zooming out and showing you the so our neighboring stars, like the closest ones to us. Which are like 4 light years away, and then zooms out even more, and it's like every single one of those stars could have planets
Yeah,
in that Goldilocks zone. In fact, we spot them. We do spot them, and then you go out and you've got billions and billions and billions of galaxies, all with billions and billions of stars, and it's just freaking huge. Like
it's
we've gone on to like alien life now, but
yeah,
it's just it's too big.
yeah. If it's not there, it's possible to be there, and it's just it's just a case of time and the correct
Yeah.
correct ingredients. You know, I mean, it's almost
And
certainly
imagine
there.
if Perseverance comes along and it finds, old. I mean, I guess with the implication of it being that close to our planet, there's nothing to say that maybe there wasn't some kind of event which linked our two planets together,
There
and
was, and
so the origins of life on Mars.
yeah. So there was. It was Jupiter came through the asteroid belt. It essentially, it's a really weird. It was in the Jupiter episode for and the Mars episode that Brian Cox did on planets. And so Jupiter comes through the asteroid belt. Essentially, its gravity, because it's so massive, like just ripped apart the sort of orbit of Mars, and then Saturn came in and dragged Jupiter back out past the asteroid belt again. It's but Jupiter was early for our solar system. Like when the sun first turned on, so when the all the gases and all the sort of it's crazy. I don't know how to describe the beginning of a
This is a
star.
funny way of putting it. When someone first switched the
Well,
sun on.
when the sun first ignited, I guess is the way you'd say it.
You mean when it starts when
yeah,
the helium first starts fusing,
when
and
the
yeah, that nuclear
essentially
reaction starts taking place.
what I mean is when the sun first turned on,
Yeah.
Jupiter was already there.
Yeah.
I'm saying it how I want to
I
say
don't
it.
actually know like the origins of when someone just flicked the sun on.
This JD's already gone to my head.
Yeah, man. Yeah, me too. And
I
it's
love
really
it, though.
bugging me because there was this thing that I said earlier, right when I started talking about the radioisotopes in the power source for Perseverance. I was like, oh, I want to talk about this one thing, and I've completely forgotten what it was.
For the power isotopes.
No, there was something else. I was like, all right, I'm going to say there's something I really want to talk about, and it's this, and then there was going to be something else. The
You
thing
do
that
this
I actually
every
wanted to talk
episode.
about more.
You do this every episode.
Freaking episode.
Every
I
episode,
know.
we come off.
And
We
I'll
were talking
remember it
about
as soon as we
AI, and then we
start.
come off, and you're like, "Oh, I wanted to talk about the Alpha Dog, which is like the most interesting thing I've ever heard." And I'm like, "I've not seen that. Why didn't you bring that up?" And you're like, "No, I forgot
Oh
about
my
it."
god. Alpha dogfight. Yeah, Alpha
Do it. Tell
dogfight.
him now. Tell him now.
The AI that's being
No one's
fighted
listening.
by.
Tell him now.
There's a thing out there created by Heron Systems when we were talking about AI, and oh my god, it was about the AI. The Perseverance has machine learning on it.
Does it? Oh, amazing. See, I knew I could jog your memory.
That's what it was. Oh, thank you. In its pathfinding abilities, Curiosity has to send data back and decisions made by people, whereas Perseverance has basic, it's not really AI, but it has machine learning, where basically what it's done is it's landed there and it can operate almost continuously, because Curiosity, it's kind of like, okay, you give it some instructions and it's like, go here, do the, like, so, go from A to point B and do C. Whereas with Perseverance, it lands there and they basically just say, okay, go do science.
Really?
And it works it all out for itself. It's operating completely autonomously.
Is it really? Because that's when I was watching.
Yeah.
I've only seen The Martian
So
once.
it's got a neural network in it.
Right. Okay. I've only seen The Martian once, and that thing, and with sort of the rovers as well. When I'm thinking about the rovers, and I think, oh god, just getting anything done is so arduous because you're constantly waiting 7 minutes for it to
I know.
react.
I haven't even seen The Martian.
I've seen The Martian, but I only watched it once, and yeah, it was good. It was good. It wasn't great. It was good. It's not the best film that Matt Damon's been in.
I do want to watch it, but
as a spacefaring traveler, but we won't bring up spoilers. So, Here's another film in space.
Yeah.
And we
Yeah.
hate it, and we
My
hate
favorite film.
it. Is that your favorite film in space?
Yeah.
I was
That's
going to
my
say,
favorite film of
about,
all
if we're
time.
talking about space, what's your favorite space film? A lot of people obviously would say
It's Interstellar.
2001: A Space Odyssey. But it's Interstellar for you, is it?
Yeah. No, for
Okay.
me, it's Interstellar.
I think
I
it's
just
got,
love how they go onto topics like time dilation, and it's kind of like that's the kind of topic which your average person doesn't think about. They have
mm,
no idea that time is subject to warping and just like space is. I mean, maybe people don't even think about the fact that space is vulnerable to being warped. But like when you have something so great in mass, like a black hole that's warping the fabric of space time, that's a concept which is just it's impossible. I remember when I
yeah,
first found out about it, I was like, "What?" I couldn't sleep. Like the
yeah,
fact that time, something you think of in our human perspective of how linear it is, it's something that can be misshapen
yeah.
is like,
I
and
mean,
that for that
yeah.
reason, it will always be my favorite.
When I did A-level physics, there's two things that I was most interested in. One of them was all of the quantum stuff, which I find just
Hmm.
mind blowing. And the other one was all the time dilation stuff and the energy stuff, which is all on a large scale. What we're talking about now, really. Physics is amazing.
Hmm.
I love hearing really intelligent people discuss physics and just talk you through. Just it was
Not
one
like
of the
this.
reasons I love Mark Rober, because he was an engineer for NASA. Now he's got a YouTube channel and
Hmm.
he makes stuff. And he did that like the parcel, when people steal the parcel and it gets just blows glitter on them. But he also like made a lot of
Yeah,
stuff Curiosity rover. So a lot of the tech that's on the Curiosity rover is made by him or his team. And I just, when he describes physics and stuff, I just go like, oh man, I love it. Like the it's such an
yeah,
interesting,
yeah. It's
like,
amazing.
it's, and in the fact that you can test it all as well. You can do it all. You can do moving clocks run slow as an
Yeah.
experiment. You know, it's very difficult,
That's the
but
thing, because
you can
it's
do
like, oh, it's
gravity.
all well and good. It's all well and good saying that if you're traveling close to the speed of light or you're right next to a black hole, then time's going to go slow. It's like you can't really
But I mean,
conceptualize that because it's not something that's
it plays into it way before you get to the speed of light. I mean, even if you think about if you
that's the
have
thing.
GPS,
Japanese bullet train. It's observable
Japanese
on the
bullet train,
Japanese bullet
yeah.
train.
But you know,
Yeah,
GPS. So if you've got a location on your phone and you're saying, "Where's this phone? Where's that person? Where's that person?" You have three different satellites, which say, "I've got him here on this location, here on this location, here on this," and it pings off to both of them, all three of them. But
triangulate.
it has to adjust the time for all of the satellites based on your place, because obviously the
Based
speed
on the
of
time
light
zones.
yeah, changes
Yeah.
how that works, and obviously the
Yes. So
satellites are
it's
moving.
completely, like I say, it's completely testable. So it's
Yeah,
kind of like, oh, if you have any doubts about it, it is actually observable and testable on Earth,
yeah, it's madness, isn't it?
which just blows my mind even more.
You can measure it
Mm.
from really high altitudes
Yeah.
as well. So if you measure your clock, if you were, say, climbing a really high mountain, it would be moving. How would you say? It would be moving slower than if you were down on Earth, closer to the center of
It's
gravity.
so many fractions of a second, though.
Oh yeah, I mean,
It's
you
such a
can,
you
yeah,
need like a quantum clock to measure the
yeah,
differences,
not on the scale of interstellar with black holes. There, you know
but
what I
it
mean?
is still there.
Hmm.
No.
But I bet those, you know, these intersolar system travel rockets, you know, the speeds they're traveling are just absurd. You know, just absurd
Yeah.
speed.
Yeah, they are.
Everything has to travel so fast in
And
space,
there's,
so, and we're still slow. We're still so slow.
the thing is even if you travel, even if you travel at the speed of light, you're still slow. The speed of
Which,
light is rapid. Like it's the fastest thing. It's the universal speed limit. You know, you
Yeah.
don't go faster than it. You don't go faster than
Well, you
it. But
can.
all
You
science and physics
can.
break down if you get something that goes faster than it. But the thing is that's still slow. It's like, oh, what, you want to travel? You want to travel to another galaxy? And yeah, okay, we can get you going at the speed of light. It's still going to take you fucking 40,000 years.
Yeah, it's madness
It's
in
going to take
terms
you
of
millions of years.
yeah. So, like you were saying earlier about how far away did you say Alpha Centauri was? 4 light years.
For Alpha
Proxima Tauri.
Proxima Centauri? Proxima
Yeah,
Centauri.
Proxima
Yeah,
Centauri.
that's the closest one. That's 4 light years away.
So 4 light years. So the light we're seeing from that sun or that star
It's 4
is
years old.
4 years old. So what we're seeing is a 4-year-old version
Mhm.
of, we essentially have a
4
delay of
years.
4 years until
Yeah,
that
4
signal
years
reaches
into the
us.
past.
So if we were
Yeah.
traveling at the speed of light, it would take us 4 years to get there. We can't travel anywhere near that speed.
Yeah.
But if you
No.
could, which you can't, but if you could, I think maybe people always say, "Why can't you?" I guess maybe I don't know how. I mean, yeah, it's a weird one, isn't it? Because we understand it. I don't know how many people know about all the ins and outs of sort of light travel and stuff. The reason you can't travel that fast is because of Einsteinian physics, which says if you anything with mass essentially cannot go at c, which is the universal constant speed of light.
Mhm.
Um, so
Exactly.
because
Yeah.
if you had mass, you'd have to have infinite energy. So E equals mc squared. What that means is energy times mass. Equals mass times the speed of light squared.
Times
But if you
times
had
the speed of
any
light
mass,
squared, yeah.
so if you had any mass at all, the energy would have to be infinite for you to go that
Mhm.
fast, and you can't have infinite energy because you could
Travel
never
that
put
fast.
yeah, so you could never travel that fast. But as you go faster and faster and faster, you'd need more and more and more energy until you reach that place where it would just become impossible.
Yeah.
Um,
And then you need that same energy to slow down again.
no, you wouldn't. You'd need a really big brick wall.
Yeah. You
Which
know,
is funny, actually.
I heard something the other
You'd,
this
you'd, you'd need a
delay,
sun,
man,
mate.
this
I
is
tell you what,
crazy.
if you were traveling at the speed of light and you had mass and you hit the sun, mate, you'd slow down. I'll tell you that much. Or would you? Would you just
Yeah.
implode the star?
Yeah. We just right through it.
Yeah.
Yeah.
Jeez.
You'd slow down. But I heard something the other day. There's the Hank Green guy that I like talking about. And he was saying about how, you know, so the speed of light, like if you were to try and get information to the moon, obviously that's a pretty short distance. It's like a couple seconds. But like if you had a pole, if you had a pole which was in your hand and extended all the way up
Yeah, yeah,
to the
yeah,
moon,
yeah.
and there was a button on the moon, and you could just push the button on the moon, would that information then travel faster than the speed of light? And it wouldn't. It would actually travel at the speed of sound because it's the sound through the pole.
Yeah, it's a
So
vibrational
that
sound,
means
yeah.
that as you moved your hand, yeah, exactly, the button wouldn't be pushed until the actual sound waves traveled through all the molecule, the atoms
Yeah.
that make up that pole, and then reached the top before it even knew that it had been pushed. So it would actually, you don't beat the speed of light.
No, well, theoretically you could. And that would be to obviously, a lot of science fiction goes along the lines of you're warping space. So you're pulling it in and pushing it out. So you're essentially bending space time,
Contracting and expanding.
contracting, expanding, or
Yeah, but
folding it
that's
over
not
on itself.
traveling. That's exactly, but
You're not traveling at the
that's
speed
not
of
traveling
light,
faster than the speed of light.
but it is
Exactly. That's
relatively.
the thing. It's like, yeah,
It is
okay, there might be
relatively.
a theoretical ways, yeah, to travel
Yeah.
distances greater than in a speed greater than light could traverse it, but only by bending space,
Yeah.
which is
And the light would still
like
travel
that's
faster if you bent the space as well.
yeah,
But yeah.
yeah, yeah, it would.
Because the light would still
But
go
imagine that
through it faster than you.
be going through your warped space. Yeah.
Yeah.
Well, yeah, it'd be
Yeah.
weird if you could beat your own light there.
Wow. It's relative, isn't it? So if the light didn't
There's
get it would have to, anything traveling on that path would have to warp space. And obviously a wormhole is where you have
would
space
yeah,
folded in on itself and you have a hole between the two and punch through. Essentially, if you had a piece of
piece of
paper,
paper.
if this is space, you'd fold
Exactly.
space
Piece of paper.
like this and then travel between
Punch a
these
hole
2
through it.
points as opposed to the whole way along the top. Um,
Yeah.
which is an interesting concept. And I think that's what they did in Donnie Darko. That was the idea of Donnie Darko, is that there was a wormhole. And I think they actually did
Yeah.
that in Interstellar as well. They had the wormhole, didn't they? That's how they got to the other galaxy, or not the other galaxy, the other solar system.
I think they used the paper analogy.
Did they? I think everyone does.
Is it in another galaxy? I think they use the paper analogy. Yeah. Yeah, exactly. You bend it over and put a pencil through it.
Everyone uses that.
But I have a
the best
feeling,
way to
is it in
describe
it is still in the Milky Way, isn't it? Yeah.
I don't know. I don't think it matters, does it? Because at that point you've bent it anyway, so it's like
Once it's that far away, exactly.
it makes no
Yeah.
difference. It makes no
Yeah, that's
difference.
very, very
I feel like we're waffling now. Shall we end the episode?
true. What are we doing?
This is going in the episode. Hold on. So is this. So is this. Wait. Rich.
Don't do it. Welcome to Dope Rope. Our first episode with alcohol and last. Thanks for watching Dope Rope, guys. If you want to check out any more amazing, stupid, and completely incoherent content, then don't forget to like, subscribe down below, check out the merchandise, and we'll see you next time.
Thank you for flying with Dope Rope Airlines. If you want to collect your possessions from the hangar above and have a safe trip on Mars. We'll see you next time for more great content. Oh, that'll do. I'll cut something out of that.